Welcome to the Tall and Urban podcast by the Council on Tall Buildings and Urban Habitat. This is Daniel Safarik. This is Season 1, Timber Rising, sponsored by the USDA Forest Service. We're talking with leading experts about mass timber, a way of building with engineered wood products that is gaining traction around the world. Today we're talking to Hannes Blaas, CEO of Rothoblaas USA, a manufacturer of connecting parts for wood construction. Hannes, welcome to the podcast.
Thank you.
So the first question I would have would be, in terms of its relative strength to weight ratio, how does building with mass timber compare to using steel or concrete?
So I think, the wood might be perceived as a material that is weaker compared to other more established construction technologies. But I think the problem is not that we have a weaker material. If you look at the development of timber construction in the last 20 years, we have come a very long way from where we were in the late 20th century. In making wood more competitive with other more established technologies in large construction, and in the next 20 years we will see a whole lot of innovation that will make wood even more competitive and at some point even exceed established construction methods. Wood is on one hand a lighter material than let's say concrete and steel. What that means, if you imagine a tall building and you put if you have a 10-story building, your point of gravity is somewhere at the fifth floor, and that is kind of a lever. If the center of gravity is very high mass, in the case of a concrete building, then obviously the force that is generated is also much higher versus a wood building. The qualities are actually quite good in terms of forces that are generated in an earthquake event, and also the wood and wood fasteners are quite good at dissipating energy. So, of course, wood per se, if we would have a wood fasteners also, like wood to wood joints, those are more susceptible to they break in a brittle way, while if we introduce fasteners like metal connectors, then we can engineer some ductility into the structure. I would say wood is not at a disadvantage compared to concrete and steel, but I would also not say that it is like it exceeds. I think they're on par. And then for tall wood buildings, it's certainly, wood is not a highly stiff material. So you have to also introduce some structural components that increase the stiffness. That could be, on one hand, as we've seen in some examples in some buildings, in some tall buildings, concrete core, an elevator shaft concrete core. Again, I think we have come a very long way in the last 30 years. I think concrete and steel, we have reached a point where we have already seen most of the development potential. And some talk about a sustainable singularity, where at some point we reach a moment where these sustainable construction methods catch up and exceed the efficiency of existing industries. Because of course, with steel construction, with concrete construction, it's easy. You can build it, no problem. The codes are ready. You have a lot of people who can design and build it. You have a huge supply chain. It's a commodity product. Wood is not there yet. I see that we're making huge every year. We're making huge steps towards an ever more competitive industry. While I see other construction industries stagnate.
I like the idea of a sustainable, what did you call it? A sustainable
Singularity.
singularity. Yes.
Yes.
I should hope that we will see that in our lifetimes. Can you talk a little bit about how the role of connections affects the integrity of timber construction and how changing the connection type might affect performance?
Yeah, so I always say there's no perfect connector out there. Otherwise we at Rothoblaas would also only sell one connector. There is a lot of innovation also going on in this field, in the connectors field. And now that we are facing a lot of challenges, of course, as I said, the supply chain is there's a lot of innovation in the supply chain. We have to standardize. We have to standardize details. We have to standardize construction and design approaches to make like a kit of parts that designers can use in a plug and play, copy paste type of way.
Right, and I think that I'm seeing a convergence here between arguments that have been made in favor of modular construction and arguments that are now being made in favor of mass timber construction, which is in some ways a form of modular construction. But I've heard it raised that because the timber panels are not necessarily right sized for MEP ducts and the like, that some of the time and speed advantage of those panel systems is reduced as compared to in situ construction processes like we normally do for concrete and steel.
I think there is. I think if you try to make it work, a panelized construction system, there is a learning curve, and your first project might not turn out the way you expect it to. But we have examples of some. Yeah, we have, for example, I know very well a client of ours in London. They're doing there's kind of specialized, or I wouldn't say specialized, on that particular type of work, but they do a lot of work in downtown London. And the advantage of timber there and the panelized construction approach is that they for example plan everything beforehand 100% in BIM, and so they have one model that everyone works on, and they have even also for the mechanical installation, they have every hole planned in that BIM model. They're guys on site. They don't have any other tool but a hammer and a screw gun. But what the beauty with this approach is that they not only use the BIM model for the planning of the building, but also for the planning of the site logistics and the install process. So what's challenging with downtown projects like in London, you can imagine you have to block a street of downtown London, which is a mess. It's expensive and it's a logistical nightmare. So a well-planned installation process is critical, and so what they do is they have everything planned out daily. So they have a daily schedule for containers. They have a warehouse a little bit outside London, and they have just in time delivery of material to site, and then everything goes up as planned. So and again, they're not allowed to do any modification of any panel on site. I was not on their first. I was not. I was not on their first project, but I can imagine every company has at first a certain a certain learning curve, and it didn't play out this the first time, but it's like building a car factory. It takes some time. It's like a clockwork that needs to start running, and you have to fine adjust and fine tune a few processes, but in the end you can gain big efficiencies with that. And and with the advantage with timber and in general, you were talking about moving material. Moving material is also facilitated because timber is just a quarter of the weight of concrete, so you can bring in more material with less trucks, and you also don't have waste that goes out from the site.
Right. You're not breaking up concrete. You don't have pieces of dimensional lumber that are sawed off and left in piles and that type of thing.
Yes, exactly. So I've heard that site traffic can be reduced by about 2/3, up to 2/3, 52% to 60% reduced site traffic with mass timber construction versus conventional construction.
Thank you for bringing these concepts forward in such a clear way.
Thank you, Dan, for having me, and we look forward to see what this industry brings next.